All right, you guys, some more substitutions for the second section in 5.1. When in doubt, write stuff in terms of sines and cosines, but as you can see, these are already in terms of sines and cosines. So if it looks like a polynomial, try and factor it, or if they give you something, cotangent minus cosecant, I forgot to put the theta in there, times cotangent theta plus cosecant theta, multiply them, FOIL the thing out, okay? So either factor stuff or multiply it out, and that should be the first step that you do. All right, here, to help remind you what that is, say you had 4 minus 4x. There's a 4 in common. You can factor that 4 out, and you'd have 1 minus x. Excuse me, this factors similarly. There's a sine squared in common. Factored out like you factored the common 4 out. So when I factor it out, I get sine squared times, if you need to, pretend you're dividing by what you're factoring out. If that helps you see what's left. 1 minus cosine squared. And I apologize, on the sheet that I initially printed and handed out in class, there's typos, but what's on the web page for this handout should be correct. But what I'm doing in class is different. So if you ended up somehow getting a sheet that was handed out in class and you watch this, I have a typo here, and I apologize for that. Okay, going to your Pythagorean identities now, you've got sine squared plus cosine squared is 1. Here's 1 minus cosine squared. So think of this got pulled to the other side. So sine squared is equal to 1 minus cosine squared. 1 minus cosine squared is worth, so this is worth sine squared. So I have sine squared theta times sine squared theta, which is worth sine to the 4th theta. And that would be your answer. That's written kind of sloppily. Let me write it a little better. Sine, make it look a little more like an exponent, theta. Okay? Rather than 4 theta. All right? This next one, that's like a polynomial, like x to the 4th minus 2x squared plus 1. Or if you need to help see it this way, x squared minus 2x plus 1. This would factor into x minus 1, x minus 1, or x minus 1 squared. This one would factor into x squared minus 1 times x squared minus 1, or x squared minus 1 squared. So this factors into sine squared theta minus 1 sine squared theta minus 1, or sine squared theta minus 1 squared. Now you're not done. Go back, think of the Pythagorean identity. Sine squared plus cosine squared is 1. Now be a little careful. I've got sine squared minus 1. So that means the 1 has to come over to this side, and the cosine squared has to go to that side. So sine squared minus 1 is equal to negative cosine squared. Okay? So sine squared minus 1 is worth negative cosine squared. This is worth negative cosine squared theta. So in parentheses, negative cosine squared theta squared. So that's going to be worth cosine, positive cosine to the 4th theta. Okay? That's the end of this section. Best of luck.